Okay, so AQA Core 1, Summer 2013, question 1. And the question says the line AB has the equation 3x minus 4y plus 5 equals 0. The point with the coordinates, this is part A, says that the point with the coordinates P plus 2, lies on the line AB. So this lies on this. Find the value of the constant P. So this has been a part of one of these algebra questions before, and basically, except it was the last part rather than the first part last time I saw it. So basically what you have to do is sub in these coordinates into this equation because they're on this line, and you will find out what P is. So if we sub 3, the x is P minus 4, and the y is P plus 2 plus 5 equals 0. We've got 3p minus 4p plus minus 8, sorry, careful with minuses and pluses, plus 5 equals 0. That is minus p minus 3 equals 0, and we have p equals minus 3. Okay. Part B says find the gradient of AB. So we know that the general equation of a line is y equals mx plus c. And in this general equation, we know that c is a constant and m is the gradient. So if we can manipulate this line and make it look like this, then we will know that whatever number is in front of the x is the gradient. So let's just say 3x minus 4y equals minus 5, minus 4y equals minus 3x minus 5, y equals 3 over 4x plus 5 over 4, so the gradient is 3 over 4. Okay, so part C. Point A has the coordinates, 1, 2, and the point C has the coordinates minus 5k, such that AC is perpendicular to AB. Now, if two lines are perpendicular, and then it says find the value of k, sorry. If two lines are perpendicular, we know that the gradients, when you multiply them together, equal minus 1. So we have the gradient for AB, and we want the gradient for AC. So what we're going to do is go, the gradient for AB is 3 over 4. If you times it by the gradient of AC, we'll find minus 1. So the gradient for AC is minus 4 over 3. Another way of working out the gradients, a gradient for a line, is using m equals y2 minus y1 divided by x2 minus x1. So because we know that the gradient is minus 4 over 3, and we also know that the gradient is this, we can sub our coordinates into this. So y2, let's make y2k, and y1 is minus 1, and x2 is minus 5, minus y2, which is 2. And if we just figure all of this out, then we find that k equals 10. Okay? That was quite a hard one. It's just hard to see, that's all. See what you need to do. It's not like a regular one. The line AB, this is part D now. The line AB intersects the line with the equation. So the line AB is the line 3x minus 4y plus 5 equals 0 that we started with. And this intersects the line with the equation 2x minus 5y equals 6 at the point D. So these two lines pass each other at the point D. Find the coordinates of D. So this question comes up quite a lot, and it just requires you to do simultaneous equations to find out the x and y coordinates. So the way I like to do simultaneous equations is just to make one of the equations equal something. So let's just take this one here, and 2x equals 5y plus 6. So x equals 5 over 2y plus 3. And then subbing our value of x into the first equation, we're going to get 3, 5 over 2y plus 3 minus 4y plus 5 equals 0. So this is 15 over 2y plus 9 minus 4y plus 5 equals 0, which is 15y, 9 plus 5 is 14 times 2 is 28 plus 28 minus 4y equals 0. 11y equals minus 28. I think I've gone wrong here somewhere. 15, 9 minus 4y. This is supposed to equal minus 4. 15y. Oh, this is supposed to be 8 here. So 15y minus 8y is 7y equals minus 28. So y equals minus 4. Yeah, so that's how easy it is to make a simple, quick mistake. So you need to just be really careful with that. And then now we have the y coordinate. We just sub this into one of these equations. So 2x minus 5 times minus 4 equals 6. 2x plus 20 equals 6. 2x equals minus 14. Trying desperately hard not to make a mistake again. X equals minus 7. Okay, so there are your x and your y coordinates for D. So D is minus 7, minus 4. I hope that was helpful, and thank you for watching.